Alright, so in this video we go over section 2.4 circles. So in this case we are going to learn the definition of the circle, graph some circle, and write their equations, as well as solving some other interesting problems related to circles. So first of all, let's look at the formal definition of a circle. Okay, so a circle is a set of all points in the xy plane that are a fixed distance r from a fixed point hk. The fixed distance r is called the radius, and the fixed point hk is called the center of the circle. And the standard equation of the circle with center hk and radius r, it's this equation right here. So let me just draw just a quick drawing here, just so you can see. So I'm going to take any point, I don't know, this point and that point. I'm going to draw a circle, and this point, which is the center denoted HK, is the one called the center, and the distance from the center to any of the points, it's the radius of the circle denoted r. It's lowercase r. Okay, how are we going to graph circle? Let's graph circles. Let's find the center and the radius and then graph them. So let's look at the simplest case. So in this case, when we see x squared plus y squared, there's something here that has to be understood. I'm going to rewrite it in this way. This x squared is the same as saying x minus 0 squared, and this y squared is the same as saying y minus 0 squared. And the number 16, because in the standard equation we have r squared, the number that appears here is the square of the radius of the circle. So center is located at 0, 0, which is the origin, and the radius, it's located, it's r equals to 4. How do we draw circles? The best way to draw circles, we first plot the origin, which is 0, 0, and then I'm going to count 4 units in each direction, to the right, to the left, up and down. And then I'm going to use these points to draw the circle. And we get our first circle, the drawing of the first circle. Okay, let's look at other examples. So now we don't have that x squared plus y squared from here. One thing to keep in mind from the equation, there are negatives inside of the parentheses, and the center is going to be with the opposite signs from the numbers inside of the parentheses. So let's see how is that going to work. So center, it's going to be h, which is positive 2, and k, which is negative 1. All we do is write the same numbers that are inside x and y and change the signs of it, and the radius will be r equals the number whose square is 9, which in this case is 3. So let's go ahead and draw this circle. So let's go to the point 2 comma negative 1, which is right there. That's going to be the center of our circle. From that point, we are going to count 3 units to the right, 3 units to the left, 3 units up, 3 units down. and we are going to use those points to draw the circle. See how the radius is 3 units and the center is to -1. For letter C, the center will be, notice there's no number here, so this is going to be 0, comma, the opposite of positive of +1 here, which is going to be -1. And the radius, it's going to be r equals the number whose square is 25, which in this case is 5. Let's go and plot our center, which is 0, -1. From there we count 5 units to the right, 5 units to the left, 5 units up, and 5 units down. There's one. Let's put them together and draw a circle. One more here. Center, which is 3, 0, and the radius, which is r, equals to the number whose square is 9, which in this case is 3 again. Alright, so let's go and plot the center. Go up 3 units, 3, oh wait a minute, 3, 0, which is going to be here. And then from there we are going to count 3 units to the right, 3 units to the left, 3 units up, and 3 units down. And draw our circle. Okay. Now we're going to do the opposite. Now we are going to be given the information and we are going to write the equation. Alright, first of all, before moving on, let's write down the standard form. X minus h squared plus y minus k squared equals to r squared. So that's the equation that we are going to be using in order to write the equation of the circles. Alright? Okay, so we are going to write the equation whose center h and k is 0, 0, that is x minus 0 squared plus y minus 0 squared equals r squared. In this case, r is 9 squared. We're not done yet. We are going to finish writing the equation. X minus 0 is simply x, quantity squared, that is going to be x squared, same with the y, and 9 squared equals 81. And that's final answer for this equation. For the next exercise, x minus h, which in this case is -4, be careful here with the signs, plus y minus k, which is 3 squared, equals 7 squared. Alright, so use the smile rule here, x plus 4 quantity squared plus y minus 3, we just leave the y minus 3, you don't want to expand these binomials, but at least you will be expected to simplify this square of this number, which is going to be 49. Another example right here, right? X minus squared plus y minus squared equals quantity squared. Alright, so in this case, this is h, this is k, x minus -8, careful here, y minus -5. We're going to use the smile rule twice, that's going to give us, and the radius is the square root of 13. But what are we going to do with the square root of 13? The square root with the square is going to cancel. And we're going to get x plus 8 squared plus y plus 5 squared equals 13. So that's our final answer for this exercise. Okay. Now there's another form for the equation of the circle. In this case, it's the equation that is in expanded form. It's called the general form. So from there, we're going to start with this huge looking equation, and we are going to do the completing the square. Remember completing the square from last chapter? So it's going to come in handy in this case, in this type of exercises. So in this case, they're asking to find the center and the radius of the circles given below. So in this case, in order to determine the center and the radius of the circle, we need to make sure that the equations are in the form that I'm writing in the other form. However, these equations don't seem to be in that form. So these are going to need some treatment here. Okay, what is that treatment? Well, completing the square. All right, so let's see. The first thing we do when it comes to this type of exercises is move the constant term to the right hand side of the equation, and all the terms that have x's and y's, keep them in the left hand side of the equation. So at the same time, what I'm going to do here, I'm going to group x's with x's, I'm going to leave some space here. Actually, I'm going to leave it as plus bar, and then y squared plus 4y plus number equals 7 plus number plus number. Why am I writing those two spaces? Because that's where we are going to put these numbers to complete the square, right? And the reason why we complete the square is because these are going to turn into perfect square trinomials that later will be factored to make them look like this. We are going to do it twice, one for the x's and another time for the y. So that's why we are grouping x's with x's and adding these extra bars. All right, so let's find m for the x's. So this is going to be 1/2 2 and then square. So this will be 1/2 times 2, that's going to be 1 squared, which equals to 1. Okay, so the number 1 will be here. On the other hand, we are going to have, okay, let me use a different color here. All right, this should be good. M equals 1/2 times 4, which is this 4 right here, square. So 4 divided by 2, that's going to give us a 2 squared, which is going to be 4. So that's the number that we are going to be adding here. Okay, so that's the 2 here. All right, let me clean this up. I didn't mean to. Okay. However, notice how I added a number 1 on the left hand side. If I do add a 1 on the one side, then I had to add it on the other side. Likewise, notice how I added a 4 on the left hand side. Be sure to add it on the other side as well. Alright, so Let me highlight this one right here. I'm going to factor that into a perfect square trinomial, or which is what we did in the last chapter. Square root of the first term, sine of the middle term, square root of the third term, the whole thing squared, plus square root of the first term on the y's, sine of the middle term, in this case plus, and the square root of the third term, which is 2, quantity squared. On the right hand side, 7 plus 1, that's 8. 8 plus 4, that's equal to 12. Okay, so that's going to be equal to 12. All right. So from here we get that the center is 1 comma negative 2, and the radius equals the square root of 12. Okay. Now let's look at the other exercise. Alright, so in this case, we are going to save a lot of work for part B of this exercise, because the linear term, rather, that is the term to the first power for the y's, is missing, so we don't need to do completing the square twice, but only once. Now, another very important thing, how is this exercise different from the previous one? Well, one thing to observe here is that the leading coefficients of the x squared and y squared, they have to be a 1, as we can see in the general form. See these invisible ones there? X to the first power and b to the first power can have any coefficient different than any coefficient, as long as it's not 0, but the square terms, they have to have a 1. It's not the case for these guys right here. So what am I going to do here is I'm going to divide both sides by 3 to get those simplified. That's going to give us x squared plus y squared minus 12. X equals the 0. Okay. Now this time I'm going to group the x's with x's. X squared minus 12x plus some number to complete the squared plus y squared equals, if I add a number here, then I have to add it over here as well. Okay, which in this case we have the 0 right here plus whatever number. Alright, this is the number that we multiply by a half, the magical number. 12 divided by 2, that's going to be a 6 squared, which is 36. Add a 36 here, add a 36 here. Alright? So, factoring the perfect square trinomial, we are going to get the square root of the first term, which is x, the sine of the middle term, which is negative, and the square root of the third term, which is 6, the whole thing squared, plus y squared equals 36. And now we have an equation that is what will be useful to get the center and the radius. So the center will be located at 6 comma 0. Notice there's no number here, it's a 0, and again this number changes sign when we move it. And the radius, it's going to be the number whose square is the constant term, in this case 6, because 6 squared equals 36. Okay, so let's move on to another example. A very classical problem in the next 3 exercises are classical problems involving circles. So in this case, they're asking us to find the equation of a circle whose endpoints of the diameter are these two given points. Okay, that's all the information they're giving us. Now, let's see. State the center and the radius. Alright, so in order to get the equation of a circle, we need a center and a radius. Okay, so in this case, we don't have any of them. Let's draw a picture. It might be a good idea to draw a picture here. Alright, so we're going to have the point 4, -8, I mean just roughly, and then the point 10, -2. So those are the endpoints of some circle. So the center is going to be here. Okay, look at the center. Does that look like anything you have seen before? Well, if you were thinking of the midpoint, well, then your answer is correct. So we are going to find the midpoint between these 2 points. That's going to be our center. Okay, so center given by the midpoint. Alright, and the midpoint will be m equals, again, at the x's, 4 plus 10. And then for the y value, at the y's, -8 plus -2. And here, 4 plus 10, that's 14 over 2. And -8 minus 2, that's a -10 over 2, which is 7, -5. So that's going to be, and it looks like it is 7, -5, right, from the picture, roughly. Now we need to find the radius. So the radius will be the distance from the center to any of the endpoints of the diameter. So in this case, the radius is given by the distance from the center to any of the endpoints of the diameter. And I'm going to do that here. So I'm going to find the distance between the center. Okay, so that's going to be the 0.7, -5, and any of the points. So I'm going to use, I don't know, I'm just going to use, let's see, which one is better. I'm going to use 10, -2. You could use the other, 4, -8, but it's your choice. You should get the exact same number, because again, this point comes from using these 2 points as endpoints of the circle. So this is going to be the square root of x2 minus x1, that is 10 minus 7, and the differences of the y's, -2 minus 5 squared, which in this case 10 minus 7 equals 3 squared, and -2 minus 5, -7. Let me go up here, and I'm going to simplify this. 3 squared, which is 9, plus 7 squared, that's 49. Alright, so 9 plus 49, what is that going to give us? 49 plus 9, 58. the square root of 58. Can we simplify that any further? Let's find out. So 58, I don't know, I'm going to divide that by 4. No, I'm going to divide by 9. It's not going to work either. 58 divided by 25, of course, it's not going to work. Of course, by 16 it's not going to work either. And I think that's about it. So we won't be able to simplify this number. So this is the radius. So now that we have the radius and the center, we can go ahead and write that equation. X minus h squared plus y minus k squared equals the radius squared. So x minus h, which is 7, plus y minus -5 equals the square root of 58 quantity squared. Cancel radical with exponent to get, so in this case, negative x minus 7 squared. We can use the smile rule here. Y plus 5 squared equals 58. So that is the equation. And well, we're given again the center. Let's restate it. Why not? And radius square root of 58. Another very classical problem, finding the intercept of the circle. So find the intercept of the circle with equation. Well, this is the equation. What are we going to need here? We're going to need solving quadratic equations twice. Alright, how do we get the x-intercepts? From 2 sections ago, we let y equals 0 and solve for x. So x minus 3 quantity squared plus y plus 2 in this case (0 plus 2), and that equals 25. Okay, so 0 plus 2, that's going to be 2 squared, and x minus 3 squared. So that's going to be 4 equals 25. So the next step here is to isolate x. I know what you're thinking again, just like on a couple sections ago. You want to expand the binomial. It's not necessary because that's going to lead us to a more complicated equation. So my advice in this case is keep it like this and use the square root property. I'm going to leave a space here for the radical symbol. Okay, so square root on both sides. Square root, don't forget plus minus. Cancel radical with the square. X minus 3 equals plus or minus the square root of 21. Next thing is to add the 3 to both sides. And that's going to give us x equals 3 plus or minus the square root of 21. So in this case, we are going to get 2 x-intercepts. One of them, which is going to be, so 3 plus minus square root of 21, comma 0. This is going to get divided within the negative. And the positive. So these numbers are kind of wacky, so we didn't get nice numbers. we are going to leave them like this. When you do the homework on MyMathLab, you will be expected to get numbers like this and type them like this, not using decimals or approximated, unless otherwise stated. But in this case, if they don't tell you anything, you will be expected to write exact numbers like this. Let's do the same here for the y-intercepts. For the y-intercept, we let x equals to 0 and solve the equation for y. So in this case, 0 minus 3 plus y plus 2 squared equals 25. This is going to give us 0 minus 3, which is going to be negative 3 squared plus y plus 2 squared equals 25. So this will be 9 plus y plus 2 equals 25. 25 minus 9. So in this case, next move is to subtract 9. Oh, it looks like we're going to get nicer numbers in this case. You will see. So this is going to be 16. Take the square root on both sides. Plus minus. Cancel, cancel. And y plus 2 equals plus minus 4, which is the square root of 16. So in this case, subtracting to the both sides, we get y equals negative 2 plus minus 4. So we are going to get the following set of ordered pairs. In this case, we set x equals to 0, comma, negative 2 plus minus 4, which can be subdivided into 2. It's the negative, so negative 2 plus, negative 2 minus 4, and its counterpart, negative 2 plus 4. We don't leave them like this. We are expected to simplify this. Negative 2 minus 4, that's going to give us negative 6. And 4 minus 2, that's going to give us a 2. So we are going to have 4 intercepts. Most of the times, circles can have maybe no intercepts at all, or 1 intercept, or 2 intercepts, 3 intercepts, or 4 intercepts. That's the maximum intercepts a circle may have, 4 of them. Alright, to wrap up this section, we are going to go over another very, very classical and interesting problem. Alright, so what is this problem about? So we are given this circle along with its equation. That's the only piece of information that they give us. Okay, so they're asking us to find the area of the circle inscribed inside the circle. Alright, what is the strategy here? Well, what do we need to know to get the area of the circle? To get the area of the circle, we would need the length of the side. Alright, the length of the side, and square it, because the formula to find the area of a square is length squared. But we don't know the length of the square. Alright, how do we know this point to that point on the circle? Well, we are going to use the information from the circle. In this case, this is telling us that the radius is r equals to 3, because 3 squared is that 9 that you see. So the radius is the number whose squared is the constant term or the right hand side of the equation of a circle. So that means that the distance from the center to this point is 3. The distance from the center to this point is 3. The distance from the center to this point is also 3. Again, go back to the definition of a circle, right? The definition of a circle is, let's recall it, let's put it back in. It's a set of all points in the xy plane that are a fixed distance, right? This distance is fixed. The distance from the center to any point in the circle are equidistant from a fixed point called the center, and that distance is given by the radius. So we're going to take advantage of that definition. So I'm going to use this distance right here. Again, you could use any distance. For example, what about the distance from here to there? You could figure out this distance right here, right? And then multiply by 2, and then you get the side. However, what about this leftover side? So that's not going to be useful to find some distance. So what I'm going to do is the following. I'm going to use this distance. Okay. I'm going to use this distance, and this is what I will do. I'm going to take a sample here of this triangle. Alright? So I'm going to take that triangle there. Okay, we know that R equals to 3. I'm going to take this out. Okay. I'm going to take that out. And I'm going to work strictly with that on the side. This is 3. Okay. This triangle, if you notice, it's an isosceles triangle because the side, this side, and that side, they are the same. So this is x. We can call that x and call that x. We can figure out these values of these x's there. All right. If we figure out the value of x's, then we can figure out the length of the side of the square, and then square the number to find the area of that square. So how can we relate the lengths of the side of a right triangle? If you recall a very important property by Pythagorean theorem. Alright, which states that a squared plus b squared equals c squared. In this case, this is a. Wait a minute, no, that's not it. This is a, this is b, and this is, whoops, and this is c. Okay, that's c. So using our quantities, we're going to have x squared plus x squared equals 3 squared. That's going to give us 2x squared equals 9. Okay, 2x squared equals 9. And let's solve this baby quadratic equation by dividing both sides by 2 and get x squared equals to 9 halves. Alright? What are we going to do next? Take the square root. Take the square root plus minus here, plus minus it, to get x equals plus or minus the square root of 9 divided by the square root of 2. So in this case, the square root of 9 can be simplified. That's plus or minus 3 over the square root of 2. But you may not want radicals in the denominator, so you might want to rationalize the denominator by multiplying numerator and denominator by the square root of 2. Square root of 2 times itself is going to cancel. We have already seen in another example in the first chapter how to simplify, how to rationalize denominator. So this will be 3 root of 2 divided by 2. Okay. Now, let's see. Well, in this case, from the algebraic process, we are supposed to keep writing this plus or minuses, right? However, in our context, we are dealing with a situation in geometry, so we only take the positive only. Okay, so we only take the positive one. And the reason for that is because for physical reasons, there's no such thing as negative distances. So now let's go back to the triangle here that we just constructed. Alright, so let's see. I'm going to draw it again with the corresponding measurements. 3, and we got that x is equals to 3 root of 2 over 2, and 3 root of 2, oops, root of 2 over 2. Alright, this 3 root of 2 is going to be the same as that 3 root of 2 here. 3 root of 2 over 2. Now, I'm going to take this same length here, which is going to be 3 root of 2 over 2 as well. Basically, what we are going to do is multiply this by 2. Add this 2 or multiply by 2. So, the length of the square will be 2 times 3 root of 2 over 2, which will be, actually you can cancel these 2 and get 3 root of 2. So now we know that the length is 3 root of 2. Now we are ready to find the area of this square. Area equals L squared. That's how we find the area of a square. Only plug in that number, 3 root of 2, which in this case, again, 3 squared times root of 2 squared. This is going to be 9 times, cancel radical with square, times 2, which equals 18 square units. And that's final answer, 18 square units. Alright, so this is the end of this video. Actually, this wraps up the entire chapter. I'll see you in the next video.